Hi, I'm Jessica Dean, a Principal Developer Advocate here at AWS. I'm here today to walk you through setting up your first CI/CD pipeline for Amazon Elastic Container Service, or Amazon ECS, and Amazon Elastic Container Registry, or Amazon ECR. Amazon ECS is a fully managed container orchestration service designed to simplify the deployment, management, and scaling of containerized applications. Amazon ECS allows users to define their application's resource requirements and configurations, and then it takes care of launching, monitoring, and scaling the containers across a variety of flexible compute options, ensuring the applications run smoothly and efficiently. With automatic integrations with other AWS services, Amazon ECS streamlines the orchestration process, making it an ideal choice for deploying and managing containerized applications in a cloud environment, offering developers and operators greater flexibility and control over their container workloads. Amazon ECR is a fully managed container registry service designed to host and store container images securely, enabling developers to reliably deploy and manage their application images and artifacts in a cloud environment. Amazon ECR integrates seamlessly with other AWS services, like Amazon ECS, making it easy to build, deploy, and manage containerized applications. With high-performance hosting capabilities, robust security features, and support for industry-standard container image formats, Amazon ECR provides a scalable and efficient solution for managing container repositories, ensuring that developers can easily store, share, and deploy their containerized applications across various AWS environments. There are two primary ways you can orchestrate an end-to-end software release workflow for your containerized applications: AWS Code Pipeline or GitHub Actions. Today, we will be focusing on GitHub Actions. The first thing you'll need to do is create an identity provider for GitHub Actions. You'll want to ensure you add the proper thumbprints, which you can find at the address in the description of this video. Next, you'll need to create a dedicated release role that has the necessary permission policies for the resources you'll be using with your Amazon ECS application. For the purpose of today's demo, I've added full access to Amazon Elastic Container Registry, Amazon ECS, Amazon S3, Amazon VPC, and Amazon CloudFormation. In production, you'll want to scope this down to least privilege necessary for your application. You'll also want to create a trust relationship between this role and your GitHub repo. The second way you can configure these things is by using CloudFormation templates like this one. Take a note of the ID provider and release role resources I have defined. Once you have OIDC configured, you're ready to connect your application to GitHub Actions. From within your GitHub Actions repo, you'll navigate to Settings, Secrets and Variables, and then Actions. Under the Variables tab on the screen, you'll need to add the ARN, or Amazon Resource Name, for the release role you created. Your Amazon account and GitHub repo will now be fully connected at this time. The next step is to customize your CI/CD workflow in a YAML file. Here's an example of a workflow that uses the AWS Serverless Application Model, or SAM CLI, to provision our required infrastructure, lint and test our application code, and then build and deploy our container image to our deployment environment on Amazon ECS. Once you have your workflow customized to your application needs, you're ready to commit and push your code to your repo. After you push your code, you can head on over to GitHub and check out the Actions tab to see your workflow running. You can visually see the 3 stages or jobs defined in the example workflow we just looked at: deploy infrastructure, lint and test, and deployment. Let's take a quick look at the steps running for each job. During our infrastructure stage, we start with checking out the code, and then we set up SAM CLI. Next, we configure our AWS credentials. Notice how this is done for us by assuming the role recreated with OIDC. Next, we deploy our infrastructure. Specifically, this step creates our virtual private cloud, also known as our VPC, our Elastic Container Registry, our ECS cluster, our task definition, our log groups, and everything else that is required for our application to run successfully. Once this job completes, the next stage kicks off by checking out our code again. The sample application is a node application, so we need to install any dependencies. Next, we run our linter, followed by our unit tests. Once our unit tests complete, we publish a test report. Again, once this job completes, we proceed to our deployment stage. Again, we check out our code, configure our AWS credentials, and set up our Docker build tools so we can build and push our image to Amazon ECR. Once the build and push step completes, we download the existing task definition that was created during our infrastructure stage. We fill in the new image ID with the ID of the image we just built and pushed to Amazon ECR. We deploy this new task definition to our cluster. Once the deployment completes, a summary report is published. In this example, I've taken advantage of GitHub Actions Job Summaries feature to give a visual indicator that the linting and unit tests passed. Since this sample application is node-based, I opted to use Jest for my unit tests. I made sure to add a test reporter step to the CI/CD workflow to make seeing the detailed results of these unit tests easier. Once the deployment is complete, the application URL is also printed to my Job Summaries report, making access to the newly created application super easy. Phew, we have learned a lot today. We've covered how to set up OpenID Connect for secure integration to AWS, how to configure a GitHub Actions workflow for CI/CD, including provisioning your infrastructure, linting and testing your application code, and deployment of your application to Amazon ECS. Thanks for watching.